Okay, today we're going to be learning about inverse trig functions and really the graphs of inverse trig functions, and then how to solve some unit circle issues with inverse trig. But we're going to start out just talking about the sine function. This graph here, in the first graph you see, has the sine graph in blue, and the red line represents y equals 1/2. And it went from negative 6 pi to positive 6 pi. Well, how many solutions to the equation sine of x equals 1/2? Well, it crosses here, 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 here. We've done this before, okay? So you know that the sine equals 1/2 at pi over 6, and it happens again at 5 pi over 6. It happens again when you go all the way around the circle, so you get 7 pi over 6. No. This is 13 pi over 6. Okay? In other words, you're going to be adding 2 pi k plus 2 pi k. All right, if you wrote all the solutions, you'd keep going and going and going and going. You keep adding 12 to that, and that's where you get 13. You add 12 more, and you get 25 pi over 6. You add 12 pi over 6 to that, and you get 17 pi over 6, and you add 12 more, and you get 29 pi over 6. There's lots of solutions. Okay? And it says, how many solutions are there if the sine was root 3 over 2? Well, root 3 over 2 is about 0.8, so it would go from here to here. As you see, it's going to have multiple solutions again. It starts out at pi over 3. And they want to know, is the inverse going to be a function? Well, remember when you have ordered pairs. So we had the function was the sine of x, and you plug in pi over 6 and you get a half, and you plug in 5 pi over 6 and you get a half, and you plug in 13 pi over 6 and you get a half. If I made myself a t-chart, what happens when you flip it around because you have an inverse? You have 1/2, 1/2, 1/2, and you get pi over 6, 5 pi over 6, and 13 pi over 6. Is the inverse a function? No. Okay? So, our goal today is to make sure the inverse of our function, the inverse is a function itself, all right? And the way I like to think about this is that if you think about the sine graph, the sine graph starts here and goes like that. If you turned it on its side, it's still going to go through 0, 0, okay? And it's going to go up the graph like this. And then if you come back and you do the vertical line test, you go, does it cross the graph more than once? Yes, it crosses it at all those points. So the inverse is not a function. Okay, remember, inverses reflect across the y equals x line. So what's here gets reflected over there. All right? So here's the idea. What we're going to do is restrict the domains. The sine function, I'm going to restrict the domain. This is a typo, so cross it out and fix it. It should go from negative pi over 2 to pi over 2. And I just wrote a half. I meant pi over 2. You listen, don't watch, okay? So it's negative pi over 2 to pi over 2. And the reason being, the sine graph goes like this, right? There's multiple occurrences of positive values and multiple occurrences of negative values. And by restricting the domain to here, my graph is going to go from here, negative pi over 2, to positive pi over 2. And it's only this much of the graph. There's only one answer when I say the sine of theta equals a half. The only place it happens is at pi over 6. Okay, so I only get one answer. Therefore, when I do the inverse, I'm going to have only one answer. Okay, my range is still going from negative 1 to 1. So let's put in my x values. If you put in negative pi over 2, you get negative 1. Put in 0, you get 0. And if you put in positive pi over 2, you get 1. I want you to scroll down here to the restricted domains. When you do the inverse, remember they flip-flop. So my domain goes from negative 1 to 1. My range goes from negative pi over 2 to pi over 2. All we did was flip-flop. And I'm going to change my x and y's. So this is negative 1, 0, 1. And this is negative pi over 2, 0, and pi over 2. So when I graph, this is now negative 1 and 1. This is negative pi over 2 and pi over 2. And this graph's here and here and here. The thing is you have to think about which way the curve goes. Think about your concavity. The way I remember it is, if it wasn't restricted, it would keep going down the curve like that, right? It would be going like that. But since it is restricted, I can lose the bottom half here. And I lose the bottom here so that it only goes like this. And I'm going to look for that, guys. I don't want straight lines. Because your restricted domain up here, the curve went this way. It was concave up, then concave down. Here it's concave down, then concave up. All right? We've got a restricted domain. And you can't change your mind. You say, well, I'm going to be different, and I want my domain to be from here to here instead. It's not acceptable. By definition, the domain and range of the inverse trig function, in order for it to be a function, that's the domain. That's what you're going to memorize. Okay? The cosine, on the flip side, the cosine graph starts at the top, it goes down and comes back up. Right? So if I go from 0 to pi, I now have positive values and negative values, but they only happen once. So when I make my t-chart, I have 0, I have pi over 2 and pi. This is 1, 0, and negative 1. When you do the inverse, these flip-flop. Wait a minute, we didn't fill in this is 0 to pi. This is negative 1 to 1. When you come down here, your domain's negative 1 to 1. And your range is 0 to pi. All right. So these are negative 1, 0, 1. And this is pi, 0, and no. What am I doing? Pi over 2 and pi. Oh my goodness. 0 is at 1. No, this is pi over 2. Sorry, I got sidetracked. This is pi over 2. And it's 1 at 0. So here it goes like this. It's negative 1 to 1. And my graph starts here and goes up that way. So this is pi over 2. And this is pi. And again, if you think about the graph continuing, it would be going like this, right? If it wasn't restricted, but it is. So that way you know you got your curve going straight. Okay? All right. The tangent. Well, the tangent graph is nice because when you can get, all you need is one period. It goes from negative pi over 2 to pi over 2, and you only get one answer. So it's nice. At negative pi over 2, it's undefined. At 0, it's 0. And at pi over 2, it's undefined. Okay, I like to add negative pi over 4 and negative 1, and positive pi over 4 and 1, because my range here is all reals. When you come down to the inverse, this is now all reals. And it goes from negative pi over 2 to pi over 2. And they're not included because they're asymptotes. Okay? So your asymptotes are now this way. That's pi over 2. This is negative pi over 2. It goes through 0, 0. And then we also know you have negative 1, negative 1 and negative pi over 4. So back here at negative 1, it's at negative pi over 4. And at positive 1, it's positive pi over 4. So you get your curve going in the right direction. Okay? Those are things you got to memorize. We restrict the domain so that you only end up with one y for every x on the inverse. All right, you need to know how to draw the graphs. You need to know the domains and ranges. All right. Now, notation, you can write it to the negative 1 or arc sign. They're interchangeably. They mean the same thing. All right. We use this way to put it in your calculator. Now, if you want to take this and turn it into, this is asking us what angle has a sine value of negative 1/2. To write it as an inverse function, you say negative 1/2. The inverse sine of negative 1 equals x. This is the inverse tangent of root 3 equals x. When you see an arc sign or you see inverse sine, it's asking you for the angle that has that value. You'll only have one answer for inverses because it's got a restricted domain. So when is the arc sign equal negative 1? It's at negative pi over 2. Okay? 3 pi over 2 is the same spot on the unit circle, correct? You go this way, whoop, you get here. You go this way, you get here. The thing is our domain's restricted to negative pi over 2, so that's the answer, and that is not. Okay? When's it equal negative 1/2? It's got to be down here. So it's negative pi over 6, not 11 pi over 6. When's it negative root 3 over 2? Negative pi over 3, not 5 pi over 3. Okay, when's the cosine? Negative root 3 over 2. It's negative, oh, no, it's not. The cosine graph, its domain is restricted to here. So you want negative root 3 over 2. That's here, so that's 5 pi over 6. Okay. This one, you've got to do what's inside first, inside the parentheses, and then do the outside. So it's asking you what function has a sine value, what angle has a sine value of root 3 over 2. Remember, it's restricted, so that's going to be pi over 3. So now it's asking you for the sine of pi over 3, which is root 3 over 2. Okay, this one's asking you for the sine, has root 3 over 2, that's pi over 3. Then they want the cosine of it, and you get 1/2. Good problems. What angle has a cosine value of 1/2? That's got to be pi over 3. And there's only one answer because it's restricted. Now we want the tangent of pi over 3. Well, the way I do tangents, pi over 3 is 60 degrees. So this is 2 root 3 and 1. So the tangent is, that can't be right. Oh man, I must be too tired tonight to be doing this. This is 2, this is root 3. So the tangent of that is root 3. Okay. Do it again. The sine is this, which is pi over 3. The cosine is that, which is pi over 2. I need the tangent, so get common denominators. So that's 2 pi over 6 minus 3 pi over 6. So now I need the tangent of negative pi over 6. All right, negative pi over 6 is down here, 30 degrees. So 1, 2, root 3. So it's 1 over root 3, only it's negative, which is the same as negative root 3 over 3 when you clean it up. Okay? See how fast I did all those? You have to know your unit circle going forwards and backwards. The fact that it's an inverse function, there's only one answer. It's not like the problems at the beginning where it crossed the graph several times, because we just restricted this graph to go from here to here. There's only one answer. Okay? All right, that's all I got for you. Do the worksheet. Practice, practice, practice. Know your domains and ranges of inverse functions. Know how to graph them. And know how to use your unit circle.